Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Proportions. This video will help you write a proportion, determine if a statement is a proportion, and solve a proportion. Write a proportion. Let's start with the definition. A proportion states that two ratios or rates are equal. If you earn $10 per hour, then you should get paid $30 for 3 hours of work. Since these rates of pay are the same, they can be written as a proportion. And so here you see we have the proportion $10 is to 1 hour, that's our rate on the left, is the same as or equal to $30 is to 3 hours. When you write two rates that are equal to one another, we get a proportion. There are three ways to write a proportion. You saw in our last example we had the rate of pay $10 is to 1 hour is the same as $30 is to 3 hours. Now we can write this as a proportion as two rates that are equal. We can also say this proportion or write this proportion in words. $10 is to 1 hour as $30 is to 3 hours. Now we can take this written phrase and shorten it a little bit by using semicolons. And here's how they will look using semicolons. And you would read this, $10 is to 1 hour as $30 is to 10 hours. So notice we're using the same words there to describe it. We're just condensing that by using those semicolons. Now let's take a look at an example that will help you understand how to take a written statement and translate this into a proportion. Example 1. One box of cereal costs $1.50. The cereal is advertised as 3 boxes for $4.50. Write a proportion for these events. Well, we want to go ahead and write a proportion here. We want to make sure that we're consistent. So as I set up my rates, I'm going to make sure that I set my rates up as dollars over the number of boxes. As long as I use that for a guide and I'm consistent when I write this proportion, my proportion will be accurate. So I want to write two rates that are equal to one another. In the first one, I'm going to have $1.50 is to 1 box, as in the next one, $4.50 is to 3 boxes. I could have switched this around and had 1 box is to $1.50 as 3 boxes is to $4.50. Either way would be correct. Now it's time to check your understanding of translating a written statement into a proportion. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. A 40-pound child received 1.2 ounces of medication. A 50-pound child received X ounces of medication. Write a proportion for these events. Well, I need to be consistent in my proportion. And so the way that I'm going to set mine up is I'm going to set it up pounds in the top and ounces in the bottom. As long as I'm consistent now, I'll set up the proportion correctly. So in the first one I have a 40-pound child. Received 1.2 ounces. That's my first rate. Now my second rate, I have a 50-pound child. And that child receives X ounces of medication. I could have flipped these around again and had ounces in the numerator of these rates and pounds in the bottom, and that also would have been accurate. Determine if a statement is a proportion. If a statement is a proportion, the rates or ratios in the proportion must be equal in value. To determine if the rates are equal in value, we calculate the cross products to see if these cross products are equal. So taking a look down here, I have the rate 4/8 and 3/6. And we wanted to determine if these ratios are equal in value. Well, all we need to do is check the cross products. And you can see the first one, I'm working on a diagonal here with 3 and 8. So I'm going to take 3 times 8, and that's going to give me 24. Now if we look down at the other cross product, 4 times 6, if we take 4 times 6, we also get 24. So since these cross products are both equal to 24, we know that the original statement was a proportion. Now let's take a look at an example that will help you understand how to determine if a statement is or is not a proportion. Example 2. Is the statement a proportion? Well, we have these two ratios, 30/42 and 5/7. And we want to determine if these two ratios are equal in value. Well, the quick way to determine that is to calculate the cross products. Let's take a look at this first one. I'm going to go on this diagonal here. So I'm going to take 30 times 7. And we want to know if that is going to be equal to the other diagonal, 42 times 5. Well, 30 times 7, we can do that one mentally, because 3 times 7 is 21, and then add a 0. So that's going to be 210. 42 times 5, we're going to have to do some scratch work on that, so we'll take 42 times 5. 5 times 2 is 10, carry the 1. 5 times 4 is 20, plus 1 is 21. So, since these cross products are equal in value, we would say yes, it is a proportion. Now it's time to check your understanding to determine if a statement is or is not a proportion. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. Is the statement a proportion? Well, the quick way to do this is to check the cross products. First, let's make sure the units are the same, and they are. Notice we have milligrams in both the numerators of my rates and then pounds in both the denominators of my rates. So that part's okay. Now we just got to check to make sure the numbers are going to work out. And to do that, we're going to look at the cross products. First cross product is going to be 4 times 5, and then we want to know if that's going to be equal to 18 times 12. Well, 40 times 5, that's an easy one. We can do that in our head. 5 times 4 is 20, and then we would add 1 0. So we would get 200 on the left side. 18 times 12, we'll have to use some scratch paper for that. So we'll go 18 times 12. 2 times 8 is 16, carry the 1. 2 times 1 is 2, plus 1 is 3. And then when we multiply 1 times 18, we'll just get 18. So we have 6, 11, carry the 1, 216. And you can see that these cross products are not equal. So therefore, our original statement was not a proportion. So we would say no, it is not a proportion. Solve a proportion. Proportions are useful for solving problems where something occurs with a known ratio or rate. For example, the ratio 16 to 9 can be used in a proportion to determine that a 27-inch tall HD TV display will have a width of 48 inches. Once you set up a proportion, it will look similar to the following exercises. So from our example with the television set, if we take a look at our first proportion here, we have the given ratio 16 to 9. And in this case, the television set was 29 inches high. So we need to find the width. We don't know what that is, so we represent that with a variable n. So this proportion would read 16 to 9 is n is to 27. And notice we have an unknown value that we're going to be solving for in this proportion. We also could have flipped things around and wrote the proportion that we have over here, where we have 9 is to 16 equals 27 over n. Both of these proportions are accurate. However, this first one is the one that we would prefer to use to solve for this unknown value n. What we're going to try to do is always start with the variable in the numerator of one of our ratios or rates. If we had a proportion like we have over here on the right side, where I had 9/16 equals 27 over n, we would simply flip both of these ratios so that the variable then gets to the numerator. So I would say flip the left one there, the 9/16, it would become 16 over 9, and do the same thing to the right one. Becomes n over 27. And now notice I have the variable in the numerator of my proportion, which is going to make it easier to solve for. Now let's take a look at some examples that will help you understand how to use a proportion to solve for an unknown value. Example 3. Solve the proportion. Well, we have this proportion n over 12 equals 4 over 3. And what we're going to try to do when we solve this proportion is determine that unknown value n. So we have n over 12 equals 4 over 3. To solve for this unknown value n, we want to get n all by itself on this left side of the equation, which means we need to undo or get rid of this division by 12. To undo division by 12, we're going to use multiplication by 12. Since I'm multiplying that by a fraction, I'm going to write that 12 as 12 over 1. Now, the reason I'm multiplying by 12 is those 12s are going to divide out and leave me with just n all by itself on the left side of the equation. On the right side of the equation, I also need to multiply by this 12 over 1. I need to keep the equation balanced, so whatever I do to the left side, I do exactly the same thing to the right side. Now let's take a look and see what we have left. On the left side, we have a common factor of 12 dividing out of both the numerator here and the denominator. So I'm going to be left with n over 1. Okay? N over 1. On the right side, I need to multiply these two fractions together, 4/3 times 12 over 1. Well, remember to multiply, we're going to first factor. So I'm going to factor the numerators, looking at 4. If I factor that, that's 2 times 2. 12, I'm thinking 3 times 4. 3 is prime, 4 isn't, so I need to break that down again. So that's 2 times 2. In the denominator, I just have 3 times 1. Now let's see. Common factors in both numerator and denominator, just that 3. So I'm going to divide those out. Let's take a look at now at our final answer. On the left side, n over 1, any number over 1 is just that number. So n over 1 is just equal to n. On the right side, if I multiply the numerators together, 2 times 2 is 4, times 2 again is 8, times 2 a fourth time is 16. So I get 16 over 1. Well, 16 over 1 is just equal to 16. So when I solve this proportion, I get n is equal to 16. Example 2. To make lemonade, Cassandra follows a recipe that calls for 3 lemons to make 2 quarts of lemonade. If she follows this recipe and uses 24 lemons, how many quarts of lemonade can she make? Well, let's start with that first proportion. So we have 3 lemons and 2 quarts. And that is going to equal 24 lemons. And we don't know how many quarts. So that's going to be our variable, and we'll use n for that. Okay, now let's rewrite this proportion without all of the units in there. So we're going to have 3 is to 2 as 24 is to some number n. Well, we want to get n all by itself. The first thing we want to do is get n in the numerator of this proportion. So I'm going to flip both sides, 2, 3, and then n over 24. And you can see here that we're trying to get rid of that 24, so n is all by itself. So I multiply the right side by 24 over 1. Do the same thing to the left side. 24 over 1. 24s are going to divide out on the right side and leave me with n over 1, which is equal to n. On the left side, we're going to need to factor this. So when I factor 24, I'm thinking 4 times 6. There's 4. There's 6. And then also I have times 2 in the numerator. In the denominator, I just have 1 times 3. Divide out a common factor of 3. And it looks like, we'll swing over here a little bit. On the left side then, I'm going to have 2 times 2 times 2, or 16 in the top, over 1, so that's equal to 16. And then on the right, I get n. So to answer our question, if we have 24 lemons, we're going to make 16 quarts of lemonade. Now it's time to check your understanding of solving a proportion for an unknown value. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 3. Solve this proportion. Well, you can see that we have the variable n in the denominator on the left side. So we're going to need to flip both sides of this proportion. So that's going to give us n over 3 on the left and 5 over 6 on the right. Now we're trying to get n all alone, so we want to undo that division of 3. So I'm going to multiply this left side by 3 over 1. Whatever I do to one side of an equation, I need to do the same thing to the other. So I multiply that side by 3 over 1. On the left side, you can see that common factor of 3 is going to divide out, leave us with n over 1, which is just equal to n. On the right side, we need to multiply these fractions together. So I'm going to factor this. In the numerator, 5 and 3 are prime, so they're going to stay just as is. In the denominator, however, we can factor 6 because that's composite. So that's 2 times 3 times 1. Looks like we have a common factor of 3 there that will divide out. So it looks like my final answer here is that n is going to be equal to the fraction 5/2. Question 4. The nursing program at State College accepts 3 out of every 10 students that apply. If 162 students get accepted, how many students applied? This may seem like a lot of information, but let's take it one piece at a time. Notice the first rate they give us is that 3 get accepted. So we have 3 accepted out of every 10 that apply. Okay? Now what we want to know is if 162 get accepted, so that's also going to go in the numerator. And then we want to know how many apply. Okay. So you can see that my variable is in the denominator, so I'm going to flip both sides of this. So I'm going to have 10 over 3 equals n over 162. Now to get n all alone, I'm going to need to multiply by 162 over 1. And this side by 162 over 1. Okay, the 162's divide out. We're going to get n on that side. Now on this left side, we're going to need to factor this out. So we'll go over on some scratch work. With 10 is going to be easy. Let's start there. 10 is 2 times 5. In the denominator, we get 3. It's the 1 and then times 1. It's the 162 that's causing the problem. So let's come over on some scratch work and we'll factor that out. So 162, it's an even number, so I'm going to start with 2 right away. We'll cut 162 in half. That's going to give us 81. Now we can factor 81 into 9 times 9. Factor those into 3 times 3. So there is the prime factorization for 162. 2 times 3, and then 4 3s. Okay? So it looks like now we're just dividing out this common factor of 3. And now I'm going to multiply all of that stuff together. And it's going to give us our final answer. So let's see. Going from left to right there. 2 times 3 is 6. Times 3 again is 18. 18 times 3, we're going to have to come off in the scratch work and look at that. 18 times 3 is going to give us 24, carry the 2. 3 times 1 is 3, plus 2 is 54. And then it looks like here, I'm right at this point, I'm at 54. Now I have a 2 and a 5 here. That's 10. If I take 54 times 10, that's going to give me 540. So it looks like here, if 162 students got accepted, then we would say that 540 students applied. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.